that we have for the class are more of topics which are related to your prelims examination more than mains. Nanotechnology, robotics, and then artificial intelligence. All these three topics, I would say that normally they are prelims based topics, but with AI especially, and we'll have a discussion on it, chances are that a mains based question can also be asked. Now, coming to nanotechnology first and foremost, again, from as I told you that it's a topic more important for prelims, so that's why smaller facts and concepts they become more important. So we'll first try to understand what is nanotechnology, and then some of the basic nanomaterials which are very important. For example, what is carbon nanotube, what is graphene, what is quantum dot. So all these things we'll discuss, and then all the applications and some of the issues that we have with nanotechnology. All right. So this is basically what we are going to discuss in today's class. Now, first and foremost, to start with, when it comes to this term, nanotechnology, what do we mean by nanotechnology? Let's try to understand that first. Now, nanotechnology, you have word nano. Now, when it comes to the word nano, nano basically comes from a Latin word, or that is basically for dwarf. All right, it's a Latin word which means dwarf, and that's why anything that is very small, we often use the term nano. For example, we discussed about nano satellites. So nano satellites are very small size satellites. Their mass is only up to 1 to 20 25 kg is what we had understood. So that's why we were calling it as nano satellites. Similarly, you have the Tata Nano car. So Tata Nano car is also a very compact car, and that's why they thought that they'll name it as nano. So that's why we see that in general, anything that is very small, we use the term nano. But then you might also know about nanometer. Can you tell me how much is 1 nanometer? How much is 1 nanometer? Yes, some of you already have written. That's correct. I need more answers, please. How much is 1 nanometers? Yes, 10 to the power of minus 9 meter, right? 10 to the power of minus 9 meters. Correct? So this is what 1 nanometer is. And when it comes to nanotechnology, this is precisely the scale what we are going to discuss. So 1 nanometer or anything that is around it, 0.1 nanometers, or let's say 10 nanometers, 100 nanometers, any material which is in this particular range will be called as a nanomaterial. And that's why the science that is associated with this scale is called as nanoscience. The technology associated with this scale is called as nanotechnology. Now, why this term, or let's say why this scale of 1 nanometer, why is it so important that we have an entire branch of science that just deals with this? Why is not there any micro technology or milli technology and so on? Why only nanotechnology? So, for that, understand something, that why this scale of 1 nanometer, why does it become so important? Now, this scale is very important. So, importance of nanoscale, if I tell you, let me take a blank slide for it. So if we talk about the importance of nanoscale, so why this scale is very important is because this is where all the atoms they start to organize themselves into a molecule. So you might know, I mean, from maybe class 9, 10th chemistry, if you remember at all. If you don't, I'll tell you that we have uh, entities which are called as atoms. And these atoms we had discussed in nuclear technology, that atoms are made of electrons, protons, and neutrons, right? Now, these atoms, they cannot exist independently. All right, they cannot exist independently. They will exist as molecules. So molecules are nothing but a bunch of atoms. Very simply put, you can simply say that it's a bunch of atoms. All right, so bunch of atoms put together will be called as a molecule. Now, the formation of molecule starts happening at this scale. Formation of molecule starts at this scale. So formation of molecules from atoms starts at this scale. Now, why is that important? I mean, that's fine. Molecules are formed at this level. So what difference does it make? The difference that it makes is that this is where you have all the individual properties of matter showing up for the first time. So until now, individual properties of matter, they don't show. So for example, let's say atom of oxygen. So atom of oxygen is atom of oxygen wherever it is. But the same atom of oxygen, when it starts to combine in various forms, we see that this is where the changes happen. So let's say, for example, we have atom of hydrogen and we have atom of oxygen. Now you know that these two can combine together to form water. These two can also combine together to form H2O2, that is hydrogen peroxide, right? Hydrogen peroxide. Now this hydrogen peroxide can be used as an antiseptic, can be used as an oxidizer, can be used in a lot of various industries, sometimes as a catalyst, etc. So we see that it can be used in various different industrial purposes, all right? Various different industrial purposes and some medical purposes. But we can't drink it. And please don't try at home. We can't drink it. Water, I need not tell you the importance of water. You are very much aware of it, right? So just one extra atom of oxygen has brought in all these changes, right? That these are completely two different chemicals with completely two different properties and have completely different applications. What happened? Just one extra oxygen atom. So oxygen atom independently is always oxygen wherever it is. But when it combines with something and becomes a molecule, that is where it starts to have some kind of properties and some kind of existence. So that is where it becomes very, very crucial to understand that whenever they exist as a bunch of atoms combined together as a molecule, this is where they start showing specific properties. And forget about here, we see that, okay, fine, hydrogen and oxygen, they are combining together to form a particular kind of a molecule. Even if that doesn't happen, just consider carbon. Carbon just by itself exists as coal. We had discussed that coal is nothing but carbon plus impurities, right? The same carbon also exists as graphite, and the same carbon also exists as diamond, right? So the same carbon is graphite, the same carbon is diamond. Now in this particular scenario, the only difference that we have between graphite and diamond is the fact that the arrangement of carbon atoms in graphite is different as compared to the arrangement of the same atoms inside diamond. And what's the difference that comes because of just a basic difference in arrangement? That one becomes a very precious stone for us, which is sold for very, very high price. And on the other hand, you have graphite that is used in our pencil. Your pencil has graphite. So just imagine the kind of difference that comes. That one pencil comes from, for let's say like rupees 5, and one diamond, I mean, if it's a 24 karat diamond, it will be over a lakh, correct? So that's why, just because of the basic difference in the arrangement, we see that the properties completely change. And then there's the third form, which is being burnt and being used as a fuel, that is coal. So that's why it's what, it's just the arrangement. So this arrangement, as it takes its shape, this is where we see that the properties, they start to show up, and it all happens at nanoscale. And that is the reason why nanoscale is so important, because all these properties, formation of molecules, happen at this scale. And because of this, we see that matter starts showing its macro level properties. So it all starts happening at this nanoscale, and that is the importance of nanoscale. And that's why we are looking at a complete branch of science that has been given only to the study of these kind of molecules and everything that can happen at this particular scale. So that is why this scale is so important. So we are saying that nano basically stands for dwarf, and this is the first point where we can start assembling something. This is where we start to see that there are all these properties that can start showing for the first time. The term nanotechnology was first coined by a Japanese scientist who goes by the name Norio Taniguchi. Now, when it comes to nanotechnology, that's why we are saying that it's a branch of science that deals with the minute particles in the range of 1 to 100 nanometers. So that's why when you have all these different types of materials, and we'll discuss about these materials are called as nanomaterials, which belong to this particular size. Now, when it comes to this size of all these nanomaterials, it's not that we have known about them for a very long time. We understand today that, okay, fine, this is the level that will be called as nanoscale. All these materials, they will be called as nanomaterials. They will all be called as nanomaterials. Now, our understanding of these nanomaterials is not very, you can say, old, or it's not that we have known about it for hundreds of years, and we have known at least, let's say, for 100 years. Because in cases of some of the other branches that we have discussed until now, for example, let's say space technology. Space technology is not a new branch, right? Space technology, or let's say if you talk about astronomy, astronomy is something that we have been studying for a very long time. The If you go back in ancient Indian history or ancient Greek history, etc., you'll find that there were astronomers back then. And then even if it comes to, let's say, the modern development of space technology, it has been happening for last couple of 100 years. Similarly, the energy discussions that we did, that also has been under development for more than 100 200 years now. And even biotechnology, you can easily say that at least for 80 to 100 years it has been here. A lot of researches have happened since 1900s. But when it comes to nanotechnology, compared to all these branches of science that we've discussed, it's a very new branch. The name itself, as we discussed, that the name was coined by a Japanese scientist, that is Norio Taniguchi. Even this did not happen until 1974. The naming itself happened in 1974. Before that, the first mention, you can say in a manner, of the idea of nanotechnology happened in 1959, when we had a very famous American physicist, Richard Feynman. And Richard Feynman was the one who had basically proposed the idea. He was delivering a speech where he said there is plenty of room at the bottom. So when he said plenty of room at the bottom, what he basically meant is that every research that we are doing right now, every kind of study that we are doing right now, is at a macro level, is at a level that we can see, but we do not know what lies beneath. And once we start going there, once we start going to the level which lies beneath this, we'll find that this is completely new world. And that's why he basically in a manner was proposing that now scientists and students, they should start looking what lies beneath. And that's why this speech became very very famous, and he was one of the very famous scientists of the time, you can say, or probably of the last 50 to 70 years. He has been one of the most uh, popular scientists. Even his biography has been selling uh, like bestsellers. One, it had become one of the bestsellers when his biography came out. And the name of the biography, it was itself Surely You Are Joking, Mr. Feynman. So Surely You Are Joking, Mr. Feynman, his biography became very very famous. And the reason that why the name, Surely You Are Joking, Mr. Feynman, if you read the stories that's there in that book, you'll not even understand how is it possible for one person to do all this. For example, stories from his childhood, when he was just, I think, 10 or 11 years old, when obviously what has happened with every one of us, that his mother also said that you just go to your room and you start studying, and he used to play with a radio, and radio was taken away. So he went to his room and he made his own radio. So he just went to the room and he figured out a way to make his own radio, which could catch nearby radio stations, and he was just like 11 years old. So that's why the name, Surely You Are Joking, Mr. Finman. And it's a wonderful book. I mean, for those of you who have read, if at all, then you would know that what a wonderful book it is. So he has been one of the basic point being that he has been one of the most famous scientists of the last one, you can say, last 50 70 odd years. And hence whatever he said, everyone would follow. And hence the students and the scientists, everyone started looking into this, and then we finally see that theoretically a study of all these molecular levels, it started for the first time. And then in 1974 the naming was done. But even then it was not enough, because okay, fine, you have named a branch, you've created a branch out of it, and you're still doing theoretical studies, because you do not have anything that can look at this level. You don't have microscopes that can look at a molecular level at a nanoscale. This changed in 1981 with the invention of something called as scanning tunneling microscope. So scanning tunneling microscope basically is something that was invented in 1981, and this changed the face of nanotechnology, because until now it was all theoretical. There was nothing that you could do. You can't see anything. You can just think that this should have happened, or this should happen, that should happen. This is what the theory says and that is what the theory says. But now you could see. Now you could see at this level, and you could practically observe all the nanomaterials, and hence now this starts to grow as a branch with the invention of scanning tunneling microscope. So what exactly do we have here? Just try to understand the scanning tunneling microscope in pretty basic ways. So in scanning tunneling microscope, you would have a metal tip like this. All right, we have a metal tip. Now this metal tip will be incident on a surface. All right, it will be incident on a surface, and uh, it will basically press this surface in a manner, or put some stress on this surface. Now as it puts this stress, or it puts this pressure on this surface, this is where we see that some amount of electricity is produced. Some amount of electricity is produced. In a manner, you can say that electrons are generated here. Now these electrons, they will be able to enter inside this surface. All right, they'll be able to enter inside the surface, making a tunnel for themselves, and that's why the term tunneling is being used. How many of you have seen the film Ant-Man? Anyone who has seen the film Ant-Man? Okay, many of you have. Even if you have not seen the film Ant-Man, if you know the concept, what basically happens is they're called something as a quantum realm, and uh, the hero that we have, he basically shrinks in size, becomes like an ant, and he enters inside the surfaces. So that basically precisely is what the concept of tunneling is. So they have used the concept of quantum tunneling there in as entertaining manner as possible. So so that is concept of tunneling, where the electrons will be able to make a tunnel for themselves and enter inside the surface, and that's what it is called as tunneling. So there are two important concepts. All right, there are two important concepts that work here. One, the quantum mechanical effect of tunneling, and then the second one is piezoelectric effect. So these are two primary concepts that work here. Now we say that it's a quantum mechanical effect. Now what we mean by quantum mechanical effect, when it comes to quantum, all right, so there are three terms that we are looking at here. So first term, let's say if the first term is quantum. So when we talk about quantum, so whether it is quantum physics or quantum mechanics, this in a manner you can say is the study of, I mean, just simplifying it, it's a study of all the smaller particles, molecules, or even subatomic particles. So that is called as quantum. So the because the properties at very small scale, the properties at atomic scale are very different from what we observe at our scale. The physics that governs us is very different from the physics that governs the atoms or the subatomic particles like electrons, protons, and neutrons. Their world is completely different. Their laws are completely different. Just imagine it as two different countries with two different types of government structures. So for us, the government structure is pretty different compared to the government structure of, let's say, some kind of a kingdom, etc. Right? So we have a democratic setup, they may not have. So similarly here also what we see is that the physics at our level is very different. When it comes to, let's say, the force, gravitation, etc., it's very different as compared to what happens at the atomic level. There are completely different set of principles that guide them, and that is what quantum physics or quantum mechanics is. So in a manner you can say that this is the study of small particles. Not let me not like write molecules, but instead atoms or subatomic particles. Atoms or subatomic particles. All right. So this basically is called as quantum physics or quantum mechanics. Now there are two basic principles that we are saying that govern the scanning tunneling microscope. So first one is tunneling. Now tunneling is a concept where we are saying that electrons are able to make a tunnel inside the surface. All right. So that is called as tunneling. So this is where electrons are able to enter inside a material by making a tunnel for themselves using the wave-like properties that they possess. Now, what it means is electrons basically or subatomic particles, we say that there are two types of properties that they show, that they can exist as a particle and they can also exist like a wave. So they can have wave-like nature and they can have particle-like nature. Both are possible for them. So that's what we see at this particular level for the electrons as well, that electrons can do both. And that is where they are making the use of their wave-like properties, and with the help of that they are able to make a tunnel. If they were just like particles, they would have just gone and collided with the surface. But because they are like waves, what happens is something like this, that let's say this is the surface and you have the electrons which are able to enter inside the surface like this, that they'll be able to enter inside the surface like this. So this is called as tunneling. All right, this is called as tunneling. Now after this, the second one, if you see, the second property is piezoelectric effect. So piezoelectric effect piezoelectric effect is a concept where what happens is that if you, let's say, press a surface by applying some pressure, by applying some stress on it, and because of that if electricity is generated, then we say that it is piezoelectric effect. So we see that it's a property of a lot of crystalline substances, a lot of solid surfaces, that if you compress them, if you try to pressurize them or put stress on them, they might produce electricity. So that is called as, whenever that happens with any material, it is called as piezoelectric effect. So piezoelectric effect basically is electricity generated electricity generated by applying mechanical stress or pressure on a substance. So even this is possible, and we have seen that something like this happens in solids largely. But last year actually it was in the news that for the first time in a liquid also piezoelectric effect has been observed. So until now we have never seen something like this. Until now we have never seen in a liquid that a liquid would show piezoelectric effect. But last year some of the scientists actually were able to even achieve piezoelectric effect and show piezoelectric effect even in a liquid. So these are two principles. So just remember in one line each, I mean, not to know all these stories that we have been talking about, just one line each, that what is tunneling, what is piezoelectric effect. That's it. So if you know this much, it's more than enough, because these are the principles on which this is based. So because of piezoelectric effect, it basically exerts some pressure on the surface that will release some electrons, and these electrons will be able to enter inside the surface. And as they enter inside the surface, that is how we are able to analyze this surface. We are able to see beneath this surface with the help of these electrons. So that is precisely what we call as the effect of tunneling. Now, apart from the scanning tunneling microscope, there is another microscope that developed later, which became very popular in nanotechnology, and this is called as atomic force microscope. Now, just to give you a basic idea of what atomic force microscope is, in case of scanning tunneling microscope, we are saying that electricity is being produced, and electricity or electrons will enter the surface. Something like that can happen only with metals. It can only happen with metals or conductors, because metals conduct electricity. Non-metals do not conduct electricity. So if you have a non-metallic surface, then electricity will not pass through it. So electrons will not be able to enter inside it. That is where another microscope comes useful, and this is atomic force microscope, where what we see is that there will be this, as you can see, that there will be this cantilever and the tip, which will be just trying to scan the surface. It will just try to run over the surface and scan the surface, and as it scans the surface, it will be able to analyze what the surface is. So this atomic force microscope is able to overcome the challenge that we faced with scanning tunneling microscope. The scanning tunneling microscope could only be used with conductors, but atomic force microscopes could be used for non-conductors or insulators. So that is why we see that atomic force microscope also became very, very useful. So in this, electrons will not obviously enter inside, but they will just scan this tip that you have. The tip will try to just scan over the surface, and while scanning over the surface, it tries to map the surface or map the uh, part, and that is basically how it makes its observation. So atomic force microscope overcomes the limitation with scanning tunneling microscope and can be used for non-conducting surfaces as well. All right. So it can be used for non-conducting surfaces as well. So that's why the scanning tunneling, that is piezoelectric effect, and the quantum tunneling, etc., those things do not take place when it comes to this atomic force microscope. They are only the properties of scanning tunneling microscope. Now, with the help of scanning tunneling microscope, for the first time, we were able to discover some nanoparticles. And the first nanoparticle to be discovered were fullerenes. And this basically was 1985. In 1985, fullerenes were discovered, and in 1995, a Nobel Prize was also given for discovery of fullerenes. And now you'll see that, I mean, once nanotechnology started to take a shape and became a reality, you'll see that there are a lot of prizes, a lot of Nobel Prizes that have just gone to I mean, sorry, has gone to nanotechnology. Even 2023 Nobel Prize in Chemistry goes to nanotechnology. So you'll see that every second, third year, at least one Nobel Prize goes to nanotechnology, because it's such a new science that there are so many things to discover, and we see that there are a lot of discoveries that keep on happening, new inventions that keep on happening, and people keep getting all these Nobel Prizes. sounds easier than it actually is, but this is basically the case right now with nanotechnology. Now, when it comes to fullerenes, the discovery of fullerene was very crucial because of the fact that this was for the first time that we even observed something like this. So the picture that you see right here on the screen, this is this football like structure. This is the structure of Buckminster fullerene. So now when it comes to this fullerene, what you'll see is that it has a kind of a hexagonal structure, right? As you can see, 1, 2, 3, 4, 5, and 6. Now all these ball like structures that you have, these basically are carbon atoms. All right, these are carbon atoms which are joined to one another in a hexagonal manner. So most of them are joined in a hexagonal manner. Some of them can be pentagonal as well, but most of them hexagonal manner in a football like structure. Just like how you have the vertices of the football, here you all at all these vertices you basically have the carbon atom kept. So in this manner we see that this is how the fullerene looks like. And fullerene basically is something, this was the fullerene that was discovered. Now this discovery was very very important for the fact that the kinds of properties that we saw with fullerenes were exceptional, unheard of, you can say. That the kinds of properties like very good conductor of electricity, very strong in its structure, also showing some of the other properties as well. So we saw that all these properties at the same time were never seen in one material. Some of these properties were properties that belong to metals, and some of these were properties that belong to non-metals, and all these good properties of both the worlds were present in this fullerene. So that's why this was very unique. And after this a lot of studies started happening, and this is where we came to a even better shape or even better structure that was synthesized, and this is carbon nanotube. Now carbon nanotube, again if you see here also you have the same hexagonal structure as we had with the fullerene, but this time instead of being a spherical shaped, this is now a tube like shaped. So that's why the name carbon nanotube, because it has a kind of cylindrical structure. So that's why the name carbon nanotube was given to this kind of a structure. So now when it comes to carbon nanotubes, ultimately what happens here is that these are cylindrical arrangement of carbon atoms, and again the properties that we saw with carbon nanotubes were exceptional. As you can see here, high thermal and electrical conductivity, great optical properties, high flexibility, increased stiffness, high tensile strength, which is even up to 100 times stronger than steel, very lightweight, and at the same time it has an ability to be manipulated while remaining strong. So because it can be manipulated, it means that you can use it in various different ways. You can use it in for various different applications. So that's why we see that there are all these advantages that we saw, all these properties that we saw with carbon nanotubes. And because of that we saw that there are number of applications where carbon nanotubes become very very useful. So for example, in electronics, so in electronics, they can be used for creating highly conducting wires or transistors, etc. And all these other electrical or electronic components can also be made. At the same time, they can also be used in the sector of energy, because they would be able to increase the efficiency of these batteries or these cells, etc. So for example, let's say in the lithium ion batteries, they become very very useful, because they will be able to improve the performance of lithium ion batteries or fuel cells, solar cells, etc. And all these can happen because they have a high surface area, high electrical conductivity, and that's why they'll be able to improve the energy storing capacity of all these batteries. So that's why if let's say carbon nanotubes are used in also making these batteries, it will be able to improve the performance and the efficiency of all these storing batteries as well. Then in biomedical applications also they can be used, because now in this particular scenario what happens is that first and foremost there are number of ways in which, for example, in the drug delivery systems they can be used. Now why drug delivery system? Let me go back to a figure that we had seen. If you see this, look at the size of the red blood cells. right? If you see the size of red blood cells, look at this. They are where? Almost 5 micrometer. And what is the size of carbon nanotube? Almost 5 nanometer. So in a manner, you can say that it's almost 1000 times smaller, correct? Carbon nanotubes are almost 1000 times smaller than the red blood cells. So that's why they can be carried inside the red blood cells. That's why we are saying that they can be used for drug delivery. Because if you want a medicine, let's say some medicine that has to reach a certain part of the body, then in that case, we can make the use of carbon nanotubes to deliver that drug to the required part of the body. So in this manner, we see that we actually can make the use of carbon nanotubes. And this is not even something which is in the future. All right. It's not something which is in the future. 2016 Nobel Prize. We'll keep talking about the Nobel Prizes, don't worry. 2016 Nobel Prize in Chemistry was given to manufacturing or production of molecular machines. Molecular machines. So these molecular machines basically are nothing but the nano-sized particles that actually can be used in drug delivery systems. So that's why they can actually be used here. And they can be functionalized with biocompatible molecules. They can very easily be here and they'll not become poisonous or anything for the body. So that's why they can be used. Similarly, they can also be used in making composite materials. Now, they can do that because of their strength, because of their thermal properties, that they have high thermal resistance, at the same time they have very high strength. So that's why they can be mixed with material to make stronger material, to make these component these material. Similarly, we also discussed that they are lightweight. So because of all these properties, you will try to use one of these properties wherever we want. So that's why they can be added to polymers or metals or ceramics, so that they can create strong, lightweight, heat resistant material. So that's why we see that there are so many ways in which we see that these carbon nanotubes can be used. Simultaneously, they also have environmental applications. So environmental applications mainly because, again, just going back to the same thing, high surface area. So because of high surface area, they can be used in filtration methods. For example, in water filtration or even air filtration methods or air purification methods, we see that carbon nanotubes can actually become important there as well. And that also owes to their high surface area. So because of that, they can actually be used for effectively removing contaminants from water. Then after that, aerospace applications. Now, why aerospace applications? Again, lightweight and strong. So that's why they can be used to replace all the metals, etc., that we use in making these launch vehicles, etc. And carbon nanotubes can actually be very, very important there. So that's why they can be used because of their lightweight and strength. They can be used in making aircraft and spacecrafts. So in all these cases, we see that they can become very, very useful. And these are some of the areas where we are actively trying to work, and there are some of these areas where we already are working. But at the same time, we see that there is a future where we'll be able to do a lot more than what we are doing with carbon nanotubes today. And the list is unlimited. These are just some of the examples of what can be done, but the list goes beyond, much beyond what you see on your screen. So these are just some of those examples, like clothing or semiconductor materials, spacecraft, solar panels, space elevators, energy storage, optics, radar, biofuel. All these sectors in one way or the other can make the use of carbon nanotubes. So that's why when it comes to nanotechnology, we still say that we haven't really started working on nanotechnology. There's a lot more that nanotechnology can do as compared to what we have done. We probably have not even achieved 10 or 20% of uh, everything that nanotechnology can do. The kind of work, the kind of various ways in which nanotechnology can become useful for us is unbelievable in some of these cases. But we do see that there's a future, and we do see that there's a scope where nanotechnology can become very, very useful. Okay, read this question. This was asked in your 2020 paper. Right, so many of used as carriers of drugs and antigens in the body. We just discussed that why we can do it, and even the Nobel Prize in 2016 was given for this. So this is correct. They can be made into artificial blood capillaries for an injured part of human body. All right. So first and foremost, here it says can be. Now, can be has infinite possibilities. As I told you, that these kind of things you cannot really say that can be is wrong unless you have a very strong reason to say that why this can be is wrong. So they can be made into artificial blood capillaries for an injured part of human body. Now, have we done something like this until now? The answer is no, we haven't. But can we say that in future also we will not be able to do something like this? We definitely can, right? So there, if you remember, we discussed something called as tissue engineering in biotechnology, right? Yesterday we had discussed something called as tissue engineering. So because in tissue engineering, we use biological material, but at the same time we actually are looking at nanomaterials as well, and nanomaterials can be very very useful in making artificial blood organ I mean artificial body organs and tissues, etc. So active research going on right now. The defense forces of a lot of countries have been trying it for their armies and their personnel who get injured in the battlefield, etc. So we see that, and even for accidents, etc., a lot of medical research has been happening on tissue engineering, where we are looking at an at a replacement or by making artificial body organs. So that's why in the future may be a possibility. Statement number 3. It says they can be used in biochemical sensors. Yes, they can be used in biochemical sensors. And as we just discussed here as well, that they basically are biocompatible molecules, and that's why in making biochemical sensors they can be useful. And already it has been done. It has been done by a lot of different scientific institutions. For example, even NASA has made some of the biochemical sensors which make the use of carbon nanotubes. So definitely correct. Fourth statement says, so for me I would say that this is also correct. Fourth statement says carbon nanotubes are biodegradable. Now this is where I have questions. Now, carbon nanotubes are very stable molecules. All right, they are extremely stable molecules. They are. We discussed that they have very. They are very strong as well. So their biodegradation is not that easy. For example, a natural biodegradation with the help of, let's say, microorganisms is not. We are trying to make certain genetically modified microorganisms that could act on these carbon nanotubes, but that's again active area of research. Right now, if we had to dispose carbon nanotubes, we use incineration. Incineration meaning that the carbon nanotubes will be heated to up to 800 degrees Celsius. They'll be heated to up to 800 degrees Celsius, so that they can be destroyed. So that's how we try to take care of it. All right, that is how we try to take care of it. So that's why saying that it is biodegradable, uh, for me I would say personally that this is, for me it's not correct. I mean, we shouldn't say that these are biodegradable. If it was, they can be biodegradable or they can be made to be biodegradable, then okay, fine. Because it is just like, let's say, when we are making the same genetically modified microorganisms to degrade plastic, to eat upon plastic. So in that case you can't say that plastic is biodegradable, because you are doing something to make them biodegradable artificially. They are not naturally biodegradable. So same is the case here as well, that saying that carbon nanotubes is biodegradable should not be correct. So if it was up to me, I would say the correct answer is 1, 2 and 3. But out of the 4 options there is no 1, 2 and 3. Official answer was this. I'm just writing it here. This was the official answer that UPSC had given. Do I agree with this answer? Absolutely not. I don't know why 1, 3, and 4. I don't see any reason why 1, 3, and 4. Because statement number 2, for example, let's say I can still uh, manage with statement number 4 and say that we're fine because there are special methods to degrade them. So let's call them as biodegradable. I still would be fine with it, although I'll have my reservations there. But statement number 2 is not correct. I mean, sorry, it's not wrong because it says can be. If let's say the statement was that they have been made, then in that case, obviously, it was wrong because we haven't been able to do that until now. But when you say that can be is wrong, you're saying that in the next 100 years also this will not be done. In the next 100 years also scientists will never be able to achieve something like this. So making such an extreme state, I don't know why. Anyway, this is one of the most vague questions that probably UPSC has ever asked. There is no reason why they should ask a question like this. They have to understand who they are asking the questions. There would be almost 30 to 40% of the students only who are coming from the science background. Even then, even if they are from science background, hardly 10% of them would even know what is nanotechnology. And then you are asking research based questions. I'm not sure what was going in the minds of the people who were setting this question. I'm sorry to be harsh on this, but uh, I really can't digest why such a question would be asked in the paper. uh, it's unfortunate if they do that. Unfortunately, the 2020 paper was full of such questions. A lot of science based questions that came, especially in 2020 paper, were vague. I mean, I'll show you another question where I can challenge what they have given as the correct answer. So that's very harsh on people who are not coming from this background. For me, it's fine because I mean, I've been teaching this for the last 10 years, so it's fine for me. And I come from a very strong background in science. So it's fine for me. But it's not going to be fine for the rest 99.9% of the people. So I'm not sure that why when these questions would come, but they did come. And this question did come. And even when we were doing the analysis just after the prelims examination, I couldn't fathom that what the answer should be. And even in the YouTube analysis that we had done back then, I'd given the answer as 1, 2, 3, and 4 because we were running out of options. I thought that okay, fine, they might have thought in this manner, and there I gave the answer as 1, 2, 3, and 4. And then next year the official answer comes out, and this is where they say that no, the answer has a twist. It is 1, 3, and 4. So I would like to meet the people and try to understand uh, from them that how exactly did they think and come to this answer. But this is what it is. Sorry for the rant. All right. So next is nanowires. Now, when it comes to nanowires, in case of nanowires, these are nano-sized wires, meaning very small sized wires, very small wires. And these are wires that again can be used in electronic circuits. They can be used in storage devices as well, because they would also have very good magnetic properties, very good optical properties. And because of that, they'll become useful in making nano-sized circuits, smaller circuits, so smaller electronics, and also in storage, in also improving the storage. So that is where nano wires can see their use. So they have remarkable optical, electronic, and magnetic properties, and that's why they can also be used in computing, storing the computer data. At the same time, they can also be used in building tiny transistors for computer chips, and all the other electronic devices, basically in creating nano circuits. In creating nano circuits, this is something that we can actually use. Now, coming to a very, very, very important particle, and this is graphene. Now, when it comes to graphene, if you again look at the structure, it is the same hexagonal structure, right? It is the same hexagonal structure, but this time arranged as a sheet, a two-dimensional sheet. In fullerene, it was hexagonal as a football. In carbon nanotubes, it was hexagonal as a cylinder. This time, it's hexagonal like a bed sheet. Just a small, I mean, just a two-dimensional sheet of hexagonally arranged carbon atoms. This is what graphene is. Now, the discovery of graphene happened in 2004. In 2004, it was discovered. And graphene also got Nobel Prize. Now, when graphene was discovered, the discovery of graphene was also very unique, because this was a discovery that you can also say, I mean, I'll tell you how the discovery happened. So the scientists who got the Nobel Prize for discovery of graphene, they were playing around with graphite. All right, so they had particles of graphite, and they were using sticky tapes, the cello tapes as you call them. So they were using the sticky tapes on graphite, and they were just peeling off graphite, and that is where, when they were looking at it under the microscope, they found graphene. So graphite is nothing but, you can say, the stacks of graphene one over the other. So when you arrange stacks of graphene one over the other, it makes graphite. So that is where they actually were able to uh, get graphene. This is how they discovered graphene. So probably it could have been any one of us just playing around with the sellotape and getting the Nobel Prize. But it was actually not that easy or not that simple. But actually, this is what happened, that they were actually uh, playing around, you can say, or experimenting around, a better word, experimenting around with the sticky tapes on graphite, and they were able to discover graphene. So hence they discovered graphene. Now this graphene, once discovered, it was named as miracle material. So miracle material. So what is so miraculous when it comes to miracle material? So it was seen as one of the best conductors of electricity, one of the best conductors of heat at room temperature, the strongest natural compound that was discovered ever, and then one of the thinnest compound known, with just one atom thickness, because it's a two-dimensional sheet, right? It's like a single layer of two-dimensional hexagonal lattice. So in simpler words, I can say that it is a sheet of hexagonally arranged carbon atoms. All right. So that is basically what we see here with graphene. So with graphene, we saw that there are all these properties, and that's why it was named as miracle material, because it could do a lot of things that were even unheard of until then. So we saw that there are a lot of applications. So for example, today when we see the use of graphene, we see that we use graphene to enhance the strength of other material, to make LED lighting more efficient and lasting longer. Then in electronic devices, they are used in making batteries, they are used in making, even in using as a barrier, a corrosion barrier for water diffusion and water purification. So everywhere we see that in all these cases, graphene actually is being used in today's time. Now, yes, when it comes to graphene, also when it comes to the potential of graphene, again, this is nothing compared to the properties that graphene has. These applications look like very simple applications, correct? But here we see that again, graphene, because of these properties that it has, it will be very, very useful in a lot of different ways, in a lot of different electronic devices, for example. We'll discuss that later, but we'll see that there are all these advantages that we might have with graphene. Read this question. This is a. I'll take it then, if at all I've missed your questions. Great. So 72% of you have marked C, which is actually the correct answer. Graphene is in news frequently. Was it? What is its importance? This was asked in 2011. So 2010, the Nobel Prize was given. 2011, this question was asked. It is a two-dimensional material and has a good electrical conductivity. Good is a very mild word. It is one of the best conductors of electricity. It is one of the thinnest but strongest material tested so far. That's also correct. It's entirely made of silicon. Entirely made of silicon. This is wrong. It is made of carbon, because it is made. This is where graphite is made from, and has high optical transparency. So this is wrong. It can be used as conducting electrodes required for touchscreen LCDs and organic LEDs. This is actually correct, and we'll discuss about this at a little later stage. So that's why 1, 2, and 4 is the correct answer here. Now coming to quantum dots. Now quantum dots are material, very unique material, where what we see is that these are nanoparticles which show optical properties, which show very good optical properties. What kind of optical properties? So for example, when you see, let's say when the ultraviolet light is incident on the surface of quantum dots, they would show different colors, right? They would show all these different colors, and what color they show, it is dependent on the size of the quantum dot. Now for the discovery of quantum dots, basically we see that the 2023 chemistry Nobel Prize was actually given for quantum dots discovery and synthesis. So that's why from the perspective of next year's examination, probably quantum dots are going to be very, very important. But again, they'll not go into the details of it because the chemistry of quantum dots is very heavy. It's very difficult to even understand what's going on there. So some of the basics related to quantum dots is what we need to understand. Now when it comes to quantum dots, what we are basically saying is that when ultraviolet light is incident on quantum dots, they would showcase different colors, right? They will basically when UV light hits their surface, they emit they emit light of various colors. Now what exactly, and all these colors that they showcase, what they emit, it is dependent on the size. It is dependent on the size of quantum dot. All right, size of quantum dot. So quantum dots basically, they emit various colors when ultraviolet light falls on them. The color of the light emitted is dependent on the size of the quantum dot. All right, so size of the quantum dot will determine what kind of color it will show. So as you can see here, the bigger ones, they are showing red color. The smaller ones, they are showing bluish color. So that is also dependent on the wavelength. We'll have a better understanding of it when we go to IT and communication chapter. But what you will basically see is that the wavelength of the red color is longer as compared to the wavelength of the blue color or the violet color. So that's why when you have a bigger sized nanoparticle or a bigger sized quantum dot, it will show or it will emit red color. Whereas when you have smaller sized nanoparticle, it will only let the violet color pass through it, because red color is bigger. So I mean, let's say if this is the size of the red color, this is the size of the quantum dot that is violet in color, it will not be able to pass through it. But if it is violet color, it will be able to pass through this quantum dot. Similarly, the bigger one will let uh, red color only selectively pass through it. So how it selectively passes through is a little beyond our level of understanding or what is required at our level. But just remember that these are simply based on the various colors that you know, the various components of the white light that you know, and what component of the white light will be emitted depends on the size of this particular quantum dot. All right, so I'll just write it here. Bigger quantum dot emit red color. Smaller quantum dots emit violet color. So it will depend basically on what is the size of the quantum dot. So 2023 Nobel Prize in Chemistry has been given for the discovery and synthesis of quantum dots. So that's why this time it becomes very, very crucial for the examination. Now, when it comes to quantum dots also sees different applications. For example, it can be used in photovoltaic devices. It can be used in LEDs or in specifically QLEDs. QLED stands for quantum LED. Now, if you've seen the advertisements or if you have gone to, let's say, an electronic showroom, etc., you'll see that some of the companies, they would talk about these technologies of television. So one of the popular technologies that Samsung has is QLED. So QLED basically stands for quantum LED, where they would make the use of quantum dots to enhance the contrast of colors that you see on the screen. So that's why when they advertise QLED, they would say that you get better picture, you get better contrast in colors with QLED as compared to your normal LED television. So this is how they would advertise QLED. And Samsung has been the leading manufacturer of QLEDs. And but it's not that others do not have, others also have it. But Samsung has been leading in electronics when it comes to QLEDs. So when they talk about QLEDs, basically this is LED which is using quantum dot, and that is why it shows better contrast in colors, and that is how they actually uh, advertise them as well. In the medical field also they'll be useful. We'll discuss that a little later, and can be used as photocatalyst in light-driven chemical conversion of water into hydrogen. So there also quantum dots actually can be used. So when it comes to all these quantum dots or graphene or carbon nanotubes, etc., there are various different application areas where they become useful. So for example, we have the medical field. Now, in the medical field, we discussed about drug delivery. So in drug delivery, we can make the use of gold nanoparticles. Apart from that, we discussed that we can even use carbon nanotubes for doing the same. In tissue engineering, also we discussed that carbon nanotubes can be used. In disease diagnostics, also we see that we can make the use of carbon nanotubes in many cases. Then, in making nano carriers for eye surgeries, also we can make the use of them. In making nano robots for surgeries, nanobots as they are called, they basically again will be nano sized particles or machines. They will be running inside the body, so they can also be made. And then for making nano flares in breast cancer treatment, this is where quantum dots are used. So quantum dots can be made use of here. So in this particular scenario, we see that this is how in medical field all these different nanoparticles that we have, they can become useful in one way or the other. Then in the energy sector, what do we see? That they can actually address the shortage of fossil fuels. So for example, we discussed about carbon nanotubes and how carbon nanotubes have better efficiency, correct? That they can showcase better efficiency as compared to many of the others. So in this particular scenario, they would be able to address the shortage of fossil fuels. Then similarly, in making nano generators for wind energy production, we see that we have again been trying some of the carbon based material like carbon nanotubes largely in them. Then in nanotech solar cells, again carbon nanotubes become very, very crucial in this. In making QLEDs, as we discussed, that quantum dots become very crucial. And then in making nano catalyst for hydrogen production, again quantum dots can become very crucial in these scenarios. So in all these cases, we see that they can be used. Apart from that, here we see that in case of solar cells, metal ion nanoparticles can also be used, like gold or silver nanoparticles actually can also become useful in such scenario. Then in food and agriculture, we have silver nanoparticles which have antibacterial properties. We have nanoemulsions which have antimicrobial properties. We have titanium dioxide which can be used as antibiotic agent, and we'll discuss more about titanium dioxide also later. Then after that, bioindicators for in pathogens and pesticides. Then even in nano fertilizers, you might have heard of nano urea. Nano urea has been in the news. Have you heard of nano urea? Some of you have. So nano urea has been in the news for quite a long time now. It's not that it's a current affairs of this year, but nano urea has been in the news because nano urea again shows better efficiency, largely better absorption rate. Better absorption rate. So that's why its efficiency as a fertilizer is better as compared to the normal fertilizers that we have been using. So there also we see that it actually can become very, very useful. Then in the environment for water purification, we largely can use graphene here. In making nanomaterials to reduce carbon dioxide, we can use carbon nanotubes or graphene. Both can be used in these cases. Then after that, pollution control using metal oxide nanocrystals. Then improving the air quality, again, we can make the use of carbon nanotubes or graphene in this particular scenario. And then in making nanosensors for detection of pathogens. So here we see that again, some of, especially in disease diagnosis, carbon nanotubes can become very, very crucial. Then in case of electronics, we have nanocircuits where nanowires can become useful. So we can make the use of nanowires. Then in making MRAMs or magnetic RAMs, we again see the use of nanowires in these cases. So nanowires can be used. Then the use of carbon nanotubes. So carbon nanotubes actually can be used in LEDs. They can be used in LEDs and also for making foldable displays. In foldable displays, what we have seen is that either carbon nanotubes can be used or graphene can be very, very useful. Graphene can be very, very useful because it's a very thin sheet, right? It's a thin sheet of graphene which actually can be foldable also without breaking, because it is very strong, one of the strongest known. And that's why foldable displays become very costly as well, because graphene actually is being used in some of them, or carbon nanotubes are being used. So that is one of the problems that we have seen, that wherever we have electronics which are using nanotechnology, you'll find that they are not cheap by any means. For example, even if we discuss about the QLED TVs that we just discussed, you'll find that there is a big gap in the prices of the QLED TVs. So, for example, let's say if you look at Samsung's two uh, medium range models, one of LED and one of QLED. If the QLED 55 inch is selling for, let's say, 55,000, then sorry, if LED is selling for 55,000, the QLED is selling for like 90,000 or something like that. So there's a huge gap in price, that it's almost equivalent to buying two LED TVs in the price of one QLED TV, right? So that's why we see that wherever carbon nanotubes or graphene or all these technologies or quantum dots are being used, we see that their prices are very high. In making single electron transistors, again, nanowires can become very, very crucial. And then in reducing energy consumption, so in case of quantum dots or the QLEDs that we discussed, QLEDs actually use less power. QLEDs use less power, so that's why in a manner they would be able to reduce the energy consumption also. So in electronics also we see that there are so many ways in which they can become useful. Then in various industries, for example, in aircraft manufacturing, in construction industry, in textiles, all these again largely carbon nanotubes. In all these, carbon nanotubes can become useful because construction, because we discussed about making composite material. So they can be used in making these composite material. Then after that, in aircraft manufacturing for increasing the strength, increasing the strength and making them lightweight. So in these cases, we see that they can be made use of. So carbon nanotubes can actually be used in all these cases. Then after that, in the space. Now, obviously, for reducing spacecraft waste, they can be used. Then after that, there is a concept called as space elevators. Now, space elevator is a very unique concept on which NASA has been working, European Space Agency has been working, Japanese Space Agency on their own also have been working. So they are saying that in this concept, what they're saying is that they'll make an elevator that can go from the Earth to an Earth station, to a space station. For example, let's say the International Space Station. So you'll be able to make an elevator, just like how we have elevators in our buildings, the lifts that we have in our buildings. Similarly, they are saying that between the Earth and that space station, they'll make an elevator. This is the concept of space elevators. Now, space elevator as a concept has been around for a while. It's not a new concept at all. NASA has been working on the concept of space elevators since 1990s. If I give you an example from my own life, I think it was 1999 or 2000, somewhere around that time. And we had a science exhibition, a science competition that we had in our school. And we had to make models of something which is scientific. So many students, they made volcanoes and all these things. Me along with my friend, we went along with space elevator. So this was back then that we had read about space elevator in the newspaper back then, and looked like a great concept. And we just made a model of space elevators, showed it to the judges who had come. We did not know what it is, they did not understand what it is, we got the first prize. So because obviously, because nobody knew what exactly this concept is, just that it looked like such a unique concept that nobody knew of it. And that's why they, out of maybe embarrassment or out of ignorance, they gave us the first prize. They did not even uh, ask us a lot of cross questions, etc., which used to happen for a lot of other people, because they did not know what to ask in these kind of topics. So it, as a concept, it has been around. That's why I'm giving you this example. This example is from approximately 25 years back, and yet we see that this is still under development, and for obvious reasons. You can just understand the complexity, that from the Earth to the Earth station, you are saying that you'll make an elevator. So not going to be easy, of course, at all. But they constantly have been working. NASA, along with taking help with European Space Agency, they have been working with them. And Japan on its own also has been working on this concept. So that's why we see that everywhere when it comes to applications of nanotechnology, it's almost everywhere. And you'll find that in one way or the other, even in, for example, in defense applications, in intelligence gathering, we can make smaller circuits, we can make smaller storage devices, and that can be done with the help of nanowires, right? That can be done with the help of nanowires. Similarly, in making military vests, carbon nanotubes can be used, because they'll help us in making lightweight, stab proof, or bulletproof clothing. So that's why they become useful from that perspective. And in wound care, as we discussed about tissue engineering, so tissue engineering becomes very, very crucial in this particular scenario. So that's why applications of nanotechnology is everywhere, and without a doubt, a lot of areas are still to be discovered. We are still looking at, you can say, just 20 or 30% or 10-20%, I would say, not more than that. And in all these cases, we see that uh, there are a lot of things which are yet to be done. Read this question. Nanotechnology in health sector, which of the following statements is or are correct? First, targeted drug delivery is made possible by nanotechnology. This is correct. We discussed this anyway. Nanotechnology can largely contribute to gene therapy. Can largely contribute to gene therapy. So they are, first of all, not making absolute statements here. Secondly, again, the same applies to gene therapy, just like how we are talking about drug delivery system with the help of nanotechnology. In a very similar fashion, gene therapy can also take place. Gene therapy, when it is about the addition or removal of genes, that is where nano carriers can actually be used, and that's where the correct answer here will be C. That is both 1 and 2. Now coming to India and what we have seen in India with regards to nanotechnology. Now, the Indian initiatives, you can say in a manner, started a little late. That initially, when a lot of studies, a lot of research was happening in the Western countries, in India, we saw just one or two cases here and there, and there wasn't a lot of support that was being provided by the government. So, although there were certain things, for example, ninth year, 5 year plan for the first time promoted research in nanomaterial, or there was a program on nanomaterials that was done in 2000, but it was actually 2007 when something called as the Nano Mission was launched by India. Nano Mission. Now, Nano Mission basically changed the game for nanotechnology in India. Until now, there wasn't any big support that the government had given, and this is where the things change around. That Nano Mission was taken as a part of the 11th 5 year plan to be taken between 2007 to 12, but with the success and the way we started working on nanotechnology, it was also extended to the 12th 5 year plan back then, from 2012 to 17. So for these 10 years this nano mission ran, and it gave us a lot of insights. We were able to work a lot because of all the support, and it pushed nanotechnology in India in a manner that we started doing well in this field. And that's why the data today proves that. So for example, if you look at the number of papers that have been published, the number of papers that have been published in nanotechnology, you'll see that the highest number of papers have been published by the US, the second highest number of papers have been published by China, and the third highest number of papers have been published by India. So that also shows in a manner that how much of research has been happening in India in nanotechnology. So that's why we say that nano mission in case of India was a game changer. Right? It was a game changer because it was able to do a lot of things for the Indian scientific community that until now had never happened. So nano mission, that's why it was an umbrella program where we see that there were five basic components. All right, there were five basic components that were taken as a part of this nano mission. The first one was basic research promotion. It was basic research promotion. Now this is where we saw that funding of the basic research by individual scientists or the group of scientists, and also creation of centers of excellence where all these scientists could come together and they could work together. So all these things was done so that they have this all these facilities available, and extending to that the infrastructure development. Infrastructure meaning providing them whatever they need. For example, something as simple as scanning tunneling microscope. Now scanning tunneling microscope or atomic force microscopes, these are not cheap by any means. One microscope could cost you up to 7 to 10 lakhs if not more. So for an individual scientist or an individual student doing research in nanotechnology, it's not possible, right? It's not possible for them that they'll be able to buy all this infrastructure and work on it. Similarly, even the IPRs, the intellectual property rights, even the IPRs of nanotechnology are very costly. So if let's say somebody wants to acquire an IPR and work further on it, it's not possible for them to do that at an individual level. So that is where all this support was provided by the government. So that's why we are talking about the infrastructure support in nanotechnology. Similarly, we see that nano applications and technology development programs were taken. So these basically were programs where a lot of research and development that is happening should also consult industries and industrial requirements. Meaning that if let's say industry needs something, or let's say the market needs something, then nanotechnology should try to solve that problem. The research and development should happen in that sense. So it should not be an independent theoretical research and development, but try to solve real world problems, the real world problems that are being faced by Indians or the Indian industries or the world beyond. Try to solve those problems. So that is what was promoted as a part of nano mission, that it should not just be an independent research, that every scientist in India is just doing some kind of research without actually thinking of why that research is happening. So try to solve the problem statements, try to solve the real world problem statements with the help of nanotechnology. So that also was made a part of it. Then human resource development. Now, this is where an effective education and training would be provided to the researchers and the professionals who are related to this industry. Plus, at the same time, so providing effective education and training, at the same time, it's not only about the professionals and the researchers, but even for the laws, or even for the operations, because it's a completely new branch that is opening up in India. So you would need professionals from every walk of life. So, for example, if it is about the IPR battles, then in IPR battles, you need good lawyers who know how to handle IPRs. So, there are all these things that we have to understand. And that's why, from that perspective, it became very crucial. And then finally, international collaborations. So international collaborations, when it comes to the international collaborations, this is where we see that a lot of joint exercises, seminars, etc., wherever they were being conducted, Indian scientists were also being sent there. They were being given uh, the kind of support that they need to visit all these seminars, or work jointly with some scientists of maybe some other country. And in that manner, a lot of knowledge sharing could happen. A lot of knowledge sharing also means not only advantages for India, but also advantages for anyone that India is working with, right? So from that perspective, we see that there are all these uh, important developments that happened as a part of the nano mission. So that's when nano mission became very, very crucial, because nano mission could solve a lot of problems, and it could enhance the amount of activities that were happening with nanotechnology in India. And that's why then we see that a lot of new research and development started happening in India. A lot of studies started being done in the country. Now, the challenges, that we understand that there are all these things and all these advantages and applications, but still there are problems that we are still facing with nanotechnology. First and foremost, we need improvement in the efficiency, reliability, and the safety of the products. That anything with regards to nanotechnology, if there are chances that it could have a negative impact, what exactly could be the negative impact, and how to solve that problem. So we have to look upon that also. Similarly, the cost of acquisition, as I told you, for intellectual property rights or nano infrastructure is very high. And that also is a challenge, that every time you cannot expect that so much of money would be spent on all these. So that also is a problem. Then the safety, health, and environmental risks to the consumers and the public, they also have to be addressed while commercializing these technologies. That what are the issues, or what are the health impacts, possible health impacts that people might have because of nanotechnology. So that also needs to be understood pretty well. Then poor lab firm integration. This is basically, you can say, lab firm integration mainly means that there's a gap between the research that is happening and the industrial requirements. Although it was a part of nano mission, but yet we see that they still are not working in tandem as they should. They still are working as two separate entities. So that also is something that we need to address for the better advancement in nanotechnology in India. So that is what we mean by uh, so this basically is lack of coordination between industries and research. Lack of coordination between industries and research. So that is basically what we are talking about. Then interdisciplinary nature of nanotechnology itself. Now this also becomes a challenge, because see, when we were talking about nuclear technology, the scientists and the engineers who are working in nuclear technology, they only need to know about nuclear technology. Same goes for biotechnology, same goes for space technology. But in nanotechnology, things are different, because nanotechnology is here to solve problems of other branches, right? So that's why you need to have nanotechnology plus space technology knowledge. You need to have knowledge of
nanotechnology and biotechnology to solve the problems in biotechnology. So similarly, you have to have a knowledge of at least two of the branches so that you can make the use of nanotechnology to solve the problems of those branches. So that's why it is an interdisciplinary nature of nanotechnology that also makes it difficult to work with nanotechnology. Then regulatory capacity, information asymmetry, and the absence of interagency coordination. Sorry. Now this is also a big challenge many a times in India, that even, let's say, for example, two ministries, you have Ministry of Science and Technology, and you also have Ministry of IT and Electronics. Now Ministry of Science and Technology and IT and Electronics, they are both somehow related to nanotechnology. Now sometimes some of the programs that will be taken up by the Ministry of IT and Electronics, they wouldn't coordinate with Ministry of Science and Technology, and vice versa. So now that's where there will be a lot of duplication of work, there will be a lot of duplication of funds, etc. also. So we need to optimize all this also. So we need to coordinate better between the agencies, the various agencies which are related to all these fields. So that also becomes very, very important. So that's why there are all these challenges that we have. And then lastly, the concerns with regards to nanotechnology. The first thing is about nano pollution. Now, when it comes to nano pollution, we know that nanoparticles are very small. And because they are very small, they can simply go and just deposit inside the body organs. They can keep on depositing inside the body organs, may not show any negative impact just in a day, or maybe not just in couple of days, or maybe a month. 10 years, 15 years, 20 years. This is where perhaps we'll start seeing the issues that nanotechnology will cause. So that's why we also have to understand that nano pollution can become a slow poison, just like what has happened with air pollution. That air pollution also is a slow poison. The deaths do not happen in a day. We don't want a similar fate with nanotechnology. So we need to understand these particles and what kind of harm these particles can cause, and what are the positive steps that we can take so as to curb these negative impacts. So for example, buckyball in fish. Now buckyballs are nothing but fullerenes. So these fullerenes were basically have been found in fish. Now, in fish, if fullerenes have been found, it simply means that they have acquired it from the environment, either from a smaller organism that they might have consumed, or maybe from water, or whatever they are feeding upon. Now, they will be eaten upon by a higher predator. So there also the same fullerenes will get on depositing. So in this manner, we'll see that because of the concepts of bioaccumulation and biomagnification. I'm sure that both of these topics you will cover in detail when it comes to your environment and ecology. Because of that, we see that there will be an increase. There will be an increase in their levels. Bioaccumulation, when it is happening in horizontally in a species at a trophic level, and biomagnification when it goes on from one trophic level to another, from smaller, I mean lower trophic level to higher trophic level. So because of all this, we'll see that the pollution levels will only increase. The pollution levels with from one level to another, or from lower trophic level to higher trophic level, will only increase. So that's why this also is a problem. Then titanium dioxide in sunscreen. Now, titanium dioxide is something that was hugely advertised a decade back. And there are, if you have seen sunscreen advertisements, you'll see that they'll show that these sun rays or radiations are coming, and they are just coming to your skin, touching your skin, and they are just reflecting off it, right? And they would not be able to enter inside the skin because of some technology that they are using. And this is where titanium dioxide was being really advertised a decade back, that the higher amount of titanium dioxide means that they'll be able to save you better from UVA and UVB radiations of the sun rays. So all these will be shown, that the sun rays will just reflect off the surface and nothing will happen to you. Then there was a research that was done on titanium dioxide, and it was found that titanium dioxide can cause skin cancer if used in higher amount. titanium dioxide can actually cause skin cancer. So something which was being advertised until now, all of a sudden became a big villain. That we can't, people stopped touching sunscreens whenever they found titanium dioxide written in its ingredients. So then uh, there was you can say a value that was put that only up to this amount, only up to this level, titanium dioxide could be used. Beyond that you cannot use titanium dioxide, because beyond a certain level, if you're using in higher concentration, then in that case it can become harmful for you. So I think it was something like 10 nanogram per ml or something like this was uh, the concentration level, the, you can say, the peak concentration level that was allowed. So then we saw that there was a decrease. So these are the problems, that because it's such a new science, that everything is just being discovered, and we do not know about the side effects, we do not know about the problems that it can cause. We just know that okay, these are the advantages, these are the benefits that we are getting from these materials, and later we find that although there are benefits, there are side effects. So that's why we need to understand all these concerns as well. Then after that, cadmium selenide nanoparticles leading to cadmium poisoning. Now cadmium selenide basically is used in making quantum dots. In making quantum dots we make the use of cadmium selenide. So that's why cadmium selenide nanoparticles can cause cadmium poisoning, so that also is a problem. And lack of risk analysis and regulations all across the world that we have seen. So that's why, because it's new, so everyone just wants that it should grow as much as possible. So we do not put any regulations or any laws, etc., to curb the kind of research happening in any country. So even for example, nano mission started working in India while there were no regulations in India. Regulations only started coming since 2018-19 onwards. So, and for very obvious reasons, what happens is that the government also does not want to get in the way of the basic research that is being done by the scientists of a country. And because they also know that once you start doing that, they will be restricted and they'll be discouraged, and they'll probably start moving out of this sector. So that's why the governments also many times do not take the risk and just let these kind of researches happen. So that's there are all these concerns that we have about them. Industries in the manufacturing of various products. Why? First, they can accumulate in the environment and contaminate water and soil. This is correct. We discussed that they can cause nano pollution. They can enter the food chain. That also is correct. That is what. So this is basically, you can see, in a manner, leads to bioaccumulation. And this leads to biomagnification. They can trigger the production of free radicals. Is this correct? Even this is correct. So free radicals basically are, you can say it's in simple terms, these are charged particles. All right, charged particles. Now these charged particles many a times are there in the body, and they are harmful. I mean, if they are in higher amounts, they are harmful. We use something against them. Do you know what do we use against free radicals? What do we use against free radicals? You know the name, just that you need to know the answer. Antioxidants. The much used or misused word today, antioxidants. So antioxidants basically act against free radicals. All right, it acts against free radicals and curbs the number of or amount of free radicals. So that is why charcoal is required in your toothpaste. So to curb free radicals, but a lot of fruits and vegetables have it, so you don't need to eat charcoal. So 1, 2, and 3. One last question before we take a break. This was asked last year, 2022 paper. This was asked. Caffeine was discovered. So if discovery is happening, it means that it occurs in nature. So that's why this is wrong. Nanoparticles of some metallic oxides are used in the manufacturing of some cosmetics. Yes, titanium dioxide in sunscreen. So correct. And you get the answer from here. A and C says 1 and D says 2 and 3. Nanoparticles of sub-commercial products which enter the environment are unsafe for humans. We discussed nano pollution, exactly the same concept. So this is what it is. So this brings us to the end of this chapter. Let us discuss the questions of nanotechnology after the break. It's already 6:55. Good optical properties that when ultraviolet light is incident on them, they might emit different colors, and the kind of color that they will emit will depend on the size of the nanoparticle. So this is basically the basic of any quantum dot. How nanotechnology can pollute the atmosphere by no, not by burning it. uh, Pollution basically because of the fact that these are very small tiny particles. So for example, let's say when you talk about the particulate matter, PM2.5 and PM10 particles, so these are also pollution particles. These also called cause air pollution. So not necessarily by burning it, just that their presence itself, the presence of all these tiny particles, because they are being used in so many different manufacturing activities, that's why we are saying that they can pollute the atmosphere. Why can't H2O2 be consumed? Because it's harmful, it's poisonous. How construction industry would utilize carbon nanotube? Because carbon nanotube is very strong. So that's why whenever you want to enhance the strength of any material, that is where they'll be using it. Can it act as a replacement to metallic rods? Not really replacement to metallic rods, but rather improving the quality or improving the strength of those rods. In between the two carbon balls of nano, what is the middle stick? That's not a stick, that's basically a bond, a chemical bond that binds these two carbon atoms. How atomic force microscope works? Basically by scanning the surface, as I told you, that it will just scan over the surface and try to analyze the surface, and hence they'll try to understand the properties of these materials. If the size of particle is even smaller than nano, then will the particle exist independently? So it all depends on whether the particle that you're talking about, is it an atom or a molecule. If it is a molecule, then in that case it can independently exist. But if it is an atom, then it cannot exist independently. So it's not about the size, it's about the type of particle. How is water purification done by nanoparticles? The water purification basically it will be done because, as I told you, that they have large surface area, so that's why you can make filtration membranes out of them, and that's why they become useful. That is where they become useful. Why is the name Buckminster fullerene? It has been taken from the scientist who was involved in the discovery. Please explain Samsung flip mobile phones made of carbon nanotubes, or uh, largely it's graphene. The name of the book is Surely You Are Joking, Mr. Finman. Graphene again explains. So graphene, basically what we are saying is that you have hexagonal structure of carbon atoms which are arranged like a sheet, like a just like a bed sheet, a two-dimensional sheet. Biotechnology mains questions. I'll just take it. Just after these slides, I have biotechnology questions also. How nanoparticles enter the food chain? So what we discussed about the fish, that because it has been found in fish, there will be some other organism that will consume the fish. So that's why from one trophic level to another, it will keep on rising in its amount. Please repeat. Titanium in sunscreen. Not titanium, but rather titanium dioxide is used in sunscreens. So basically, titanium dioxide has properties that it will be able to reflect the radiations, the UV radiations. So that's why they are used in sunscreen. But what has been found is that if used in larger quantity, then it can be harmful. It can lead to skin cancer in extreme cases. So that's why now it has been prevented from using above a certain amount. Is nanotechnology harming the nature? No, depends on what kind of nanoparticle are we talking about. We are using nanoparticles even for filtration purposes, and at the same time they can also cause problems. So depends on what kind of particle are we discussing. Can nanotechnology be used in making triple layer civic mask? No, COVID mask. Yeah, in COVID-19 mask making also we have made the use of nanotechnology. What is blood capillary? Blood capillaries are capillaries that you have inside as a part of our system, where uh, these are the you can say thinner vessels which carry the blood. How tunneling microscope examines the surface? As I told you that the electrons will make a tunnel through the surface, and they'll be able to understand the surface better because you'll be able to get the picture of what the surface is like. Difference between bioaccumulation and biomagnification we'll discuss more in environment and ecology, but just remember that when we are talking about same trophic level, then it's more of bioaccumulation. When we are talking about one trophic level to another, then it is biomagnification. Please explain scanning tunneling microscope. We just discussed about it. To generate electricity on the surface. So basically, it's what happens is that when the tip presses on the surface, that is what actually releases some electrons. Is my messages reaching Shubit? If I've missed it, you can re-ask your question if at all I've missed the question. Tomorrow class is there or not? Tomorrow, I think you have a morning session of your economic doubt session. I think you have it in the morning, and then in the evening, our regular classes will also happen. As I've been told that there is the doubt session that we'll have in the last class, that is on Wednesday. So tomorrow will be an extra class, and then the doubt session will happen on Wednesday. So tomorrow, this is what the schedule is for you. Were you in Delhi last month? I saw someone like you in Karol Bagh. Oh, I actually was. I had visited the Karol Bagh office of Byju's, so probably you might have seen me there. So, small world. When we write answer, that time I'll write more points or more discussion. The number of points, I mean, if the number of points are, I mean, valid points, if you can use more valid points, obviously you'll have more content and it will help you. I have no books if I purchase from market. No, you don't need books. Just follow whatever we are doing in the classroom and current affairs. That's it. Please don't go beyond that. I'm on. No, I'm not on mute. I think others are getting.
the voice? Tomorrow, science and technology class will happen at the same time. Our classes will happen at the same time, 5 to 8:30. There's no change in that. But as I've been asked to announce that there is the doubt class for those of you who have attended your economy classes. So for those of you, there will be the doubt session in the morning. Anything that which can't be understood, call it as quantum in MCU. That actually is true. Not only in MCU, in any film, when they have to explain anything which is very complex, they'll use the word quantum because they know that nobody knows what quantum is. So you use the word quantum as casually as you can. Which test series shall we buy? The test series will start, I think, in the month of January. So you just continue and we'll start with the test series then. If you want additionally, there are many which are available for additional practice if you want, but don't buy additional test series. It will be very costly. So instead, you'll get the copies or PDFs, etc., everywhere. So you better practice from there. All right. So yeah, tomorrow is a class. I'm sure that it might have been given to you as a part of the schedule also. Even I was confused, but I was told that yes, there is a class tomorrow because there is the extra doubt session that we also have now. So that is being done on the last day, that is Wednesday. So tomorrow we'll have our regular classes in the evening. Right. So let's look at some of the questions that have come in the mains examination. Now, in the mains examination from nanotechnology, not a lot of questions come, but there have been a couple of questions, although very very easy questions, but they do have some questions that in the past they have asked. So if you see the first question, what do you understand by nanotechnology and how is it helping in the health sector? Now, if you look closely, there are two questions that have been asked here. What do you understand by nanotechnology and how is it helping in the health sector? So the question is not only about health sector, but it's also about nanotechnology. It's also about your basic understanding of nanotechnology. So that is basically what they have asked here, that it's not only about nanotechnology. Please remember this. They have asked both the things from you. All right. So what do you understand by nanotechnology? You have to explicitly write about this. So just understand the difference between two types of questions. One way to ask the question could have been, how does nanotechnology help in the health sector? That would have been the first kind of question. Second one, the one that has been asked here, what is nanotechnology and how does it help in the in the health sector? Now if it was the first one where they have directly asked you, how does nanotechnology help in the health sector, then the basic introduction that you would give, you would not waste a lot of words there on introduction to nanotechnology. In one line you will say what is nanotechnology and you'll say that there are various applications and health sector is one of the most important sectors that is gaining from nanotechnology. So you'll just write this much and you then will have to write the entire answer about only health sector. But in this case, the question says, what is nanotechnology or what do you understand by nanotechnology? And then the second part is, how does it help in the health sector? So then there are two parts to this answer. First, you will also write about nanotechnology because they have explicitly asked you what is nanotechnology. So you will also spend some words, right? You'll also spend some words in writing about what nanotechnology is, and then the second part, how it helps in the health sector. So that's why just be very careful while answering these kind of questions, because wherever you have two or three question marks, you know that there are two or three parts to the question. But sometimes this can also happen when there is no question mark and in a continuous manner they have asked you two separate questions. So be very mindful when you are looking at the questions, because let's say what happens is that if you directly go on to write only and only about
health sector here, you are going to lose marks, because some part of the marks will be given to just the basic idea about nanotechnology and presenting about nanotechnology. So be very mindful. And again, we discussed about health sector and all these things. We know what is nanotechnology. We discussed all these things. So a very simple direct question. Second question, why is nanotechnology one of the key technologies of the 21st century? First question, describe the salient features of the Indian government's mission on nanoscience and technology and the scope of its application in the development process of the country. So the second question also, in a manner, you can say that it has two parts, right? Describe the salient features of nano mission basically, and how is it going to help us. So first is, why nanotechnology one of the key technologies. So we discussed about nanoscale, that why is nanoscale so important. So that's the first thing that you have to write in the first part of this answer. And then in second part, it's simply about your nano mission. So you just have to describe nano mission and write the features of nano mission. So again, a very simple question, but just remember that there are all these subtle parts to this question which can be very easily neglected. Then we also discussed biotechnology yesterday. So from biotechnology perspective, also understand some of the key areas or the questions that have come. Again, you'll see that the questions in biotechnology also have been very simple. First, what are the research and developmental achievements in applied biotechnology? How will these achievements help to uplift the poorer sections of the society? So first, applied biotechnology. So we discussed about the modern biotechnology yesterday. So modern biotechnology or applied biotechnology are basically the same things, where we are talking about how biotechnology is going to help. And the entire chapter was about that, right? You basically have to summarize the chapter in this particular answer, because you'll have to write about agriculture, about health, about industries, about environment. So that's why it's going to be a difficult task, because you'll have to just compress everything that you have studied, everything that you know, into a very small number of words. How will these achievements help to uplift the poorer sections of society? Right? Poorer sections of society, how does it help in upliftment? So again, think from the perspective of employment, think from the perspective of medical help, think from the perspective of agriculture, that from how all these developments, the biotechnology based developments, how have they helped. So that is basically you have what you have to write about in this particular answer. How can biotechnology help to improve the living standards of farmers? This question is nothing but only about all these agricultural applications that we discussed, right? All the agricultural applications that we discussed in the class, that basically is what you have to write. Just that you'll have to mend your words, you'll have to fit to what the question has asked. So question is not directly about how does biotechnology help in agriculture. The question is about how does it help the living standards of farmers, right? Living standards of farmers. So that's why you'll also have to mend your ways of writing the answer to this question. All right. So otherwise it's only about agricultural application. Why is there so much activity in the field of biotechnology in our country? How has this activity benefited the field of biopharma? So again, why so much activity? Because of all the important applications that we see, because we know how much biotechnology means and how much it can do. We know about all the possible applications of biotechnology, and that's why you can write about all the research development, and this can be done and that can be done in this answer. And then finally, the second part is, how has it helped in biopharma? So we discussed about biopharma also, and we discussed about the fact, for example, that more than 70% of the money that is being spent on biotechnology is spent only on biopharma. So that's why from that perspective, you have to build your answer in that particular direction. So all these things we already have discussed, and it's nothing new, but just that you have to be mindful while writing, so that you use your best words to present your answer. The next question is about stem cell therapy, again something that we have discussed. Stem cell therapy is gaining popularity in India to treat a wide variety of medical conditions, including leukemia, thalassemia, damaged cornea, and severe burns. Describe briefly what stem cell therapy is and what advantages it has over other treatments. So from here until here, there's no question, correct? What is this? They are just being a fan of stem cell therapy, right? They are just talking about the advantages of stem cell therapy. So until now, question hasn't begun. Here the question starts. Describe briefly what is stem cell therapy and the advantages that it has over other treatments. So when it comes to what is stem cell therapy, we have discussed about this. How does it help? What are the advantages? Basically, we know that in some of the areas where we haven't been able to find ways to treat a disease, we see that stem cell therapy can actually become useful in those cases, right? Stem cell therapy can actually be used in those kind of cases. And overall, when it comes to this kind of a question, always remember that when you write answers to this kind of a question, never write negative. You see the tone of this question, it's completely positive. It is just talking about the advantages, and it is asking you also only about the advantages. So you do not just go there and start writing disadvantages and the shortcomings and the limitations, etc. Don't do that. Try to match yourself to the tone of the question. If the tone says what are the positives and the negatives, what are the issues right now that we are facing with stem cell therapy, then fine, go ahead and write about those things also. But if it does not state it, then you do not go further and start writing all these things which are negative. Even if you do, it should not be more than one or two sentences, because this question has a very, very positive tone. It's only about all the advancements and all the advantages that we have with stem cells or stem cell therapy. Then lastly, another question, a question which I wouldn't say that it was entirely biotechnology question, but it was a mix of biotechnology and economy. What is allelopathy? Discuss its role in major cropping pattern systems of irrigated agriculture. So allelopathy. Now, this is allelopathy. Allelopathy, it's not allopathy. So, allopathy, you might know, is related to medicines. Allelopathy, on the other hand, is something which is related to certain properties of plants or trees, where the growth of one plant may affect, or rather would affect, the growth and the prospects of another plant, sometimes positively, sometimes negatively. Whatever be the case, if one plant is affecting the growth of another plant, then in that case we say that it is allelopathy. So for example, let's say there are plants which fix nitrogen, right, which fix nitrates into the soil. So obviously they are improving the quality of the soil, and that will be that will be good for other plants that are growing. On the other hand, you also have plants and trees that consume a lot of water, they consume a lot of nutrients, and that's why they degrade the quality of soil, or they would even take away or eat up the nutrition or water that was meant for some other plant. So that's why positively or negatively, sometimes some, because of some chemicals also, they actually might do it. So that's what allopathy is. So in case of cropping systems, we see that that is where allopathy can be used, and it was actually in the news back then, and it was context, it was that context in which the question actually was asked. So that is, so these are the questions that have been asked, you can say, which are related to biotechnology. And as you can see, most of these questions are fairly simple and straightforward questions. Now coming to our next chapter, and this next chapter is robotics. Now robotics as a chapter, from your prelims and mains perspective, this is a chapter which I would say that I don't expect any questions to come from. In the past 15 years of question papers, if you see, prelims and mains combined, zero questions in the prelims examination, one question in the mains examination. 15 years combined. So, but it's a part of your syllabus. So I wouldn't say that. So because questions have not asked, not have been haven't been asked. So let's skip to the next chapter. I can't do that. Unfortunately, can't. So robotics as a chapter, although very small chapter, and there's a reason why questions haven't come, because we have done nothing in robotics. I mean, I mean, our country, we as a country, we have done nothing in with robotics. and no government wants to touch robotics, whether today's government or yesterday's governments or 20 years old government, they will not touch robotics. The reason is that robot is a topic, or robotics is a topic which is always also associated with a lot of job losses. That you would automate the industries, you will automate the manufacturing processes, and that would in turn lead to a lot of people losing out on their jobs, which is not a misplaced fear. It is possible, it would happen. So that is a big fear, and this is a fear that a very trivial person also understands with no technical knowledge whatsoever. So they also understand this. So that's why this becomes a big election topic. If at all, let's say somebody comes tomorrow and some government comes tomorrow and says that we are going to invest a lot in robotics and we are going to make robotics work in India, they're going to lose all the state elections in the next 1 year. So that's why no government will try to make that kind of a promise, even if it means development in one way or the other. So that's why whether it is this party or that party or XYZ party, nobody will touch it. So now coming to robotics. Now, what do we mean by a robot, and what is this robotics as a field? Now, robot basically is nothing but, you can say, these are said to be intelligent machines that can sense and manipulate the environment. Sense and manipulate the environment. Now, when we say sense and manipulate the environment, the meaning is that they can gather information from their environment and take decisions based on that, which will result in some kind of mechanical work. They'll do some kind of mechanical work. Now, when we say mechanical work, the meaning of mechanical work is something that is associated with some kind of movement, just maybe placing something from one place to another, or maybe just movement from here to there, or maybe doing something in an assembly line. So whatever it is, some kind of mechanical work. So a robot is a machine that will be able to do some mechanical work based on the inputs that it has received. All right, so that is what a robot is, and that's why the branch that of science and technology that is related to the understanding of or the working of robots, the engineering and the design of robots, will be called as robotics. Now, when it comes to robotics as a field, first and foremost, there are three laws of robotics. Now, these three laws of robotics were given by Isaac Asimov. Now, Isaac Asimov was not really an engineer who was related to the field of robotics. He was more related to biochemistry, but he has been somebody who has written a lot of science-based articles, a lot of science fiction also he has written. So he had actually given these three laws of robotics, but more than laws, these are guidelines. These are laws that can really act as guidelines. These are not laws like laws of motion or laws of physics, but these are more of guidelines for the industries which are going to use robots. So, for example, if you see the first law, a robot may not injure a human being or through inaction allow a human being to come to harm. So, neither you go and attack a human or not let anything happen to that human. That's the role of a robot. Similarly, robot must obey orders given to it by human beings except when such orders would conflict with the first law. Meaning that if a human has given some kind of instruction to the robot has to go follow it. But if those instructions are to attack somebody else, to harm somebody else, then the robot should not obey the orders. So that's the second law. And then the third law says that robot must protect its own existence as long as such protection does not conflict with the first or the second law. Right? So it also should try to preserve itself, but not at the cost of a human. So these are the three laws that were given, and as you can see that these are not laws that really are being followed by everyone. So that's why these are more of guidelines for the manufacturing industry, guidelines for anyone who's using robots. So these are more like guidelines that he had given. Now these guidelines became very very important and very popular as well, because that actually was something that the manufacturers or even the programmers were following. That programmers will make sure that they would follow all these three laws, so that they can ensure the safety of robotics or safety of robots. This would ensure the safety of people working with robots. So that's why this became a very very crucial set of guidelines, and these guidelines also have been used in films, in a lot of science fiction based films. These kind of laws actually have been used, where you'll see the violation of those laws also happening. And I'm sure you know the names of the films where you have seen the violation of these robots and these laws. And explicitly, there is a film called as I, Robot. If any one of you have seen it, the film I, Robot basically mentions these three laws as well. And even if you look at the Indian films that have been made, the two famous films where you have Sir Rajnikant, there also you'll see that you see the violation of these laws in those movies, and how violation of those laws can actually lead to some kind of a difficult scenario, right? So coming to robots, basically when we talk about robot, a robot basically has these basic components. These are said to be the components of robots. What are the components? First and foremost, we have the controller. We have the controller of a robot. The controller of the robot is like the brain. In a way, we can say that this is brain of the robot. And why we are saying that this is brain? That's the role of the brain, to control and coordinate all the activities happening inside the human body. So similarly, we have the controller, and controller will also coordinate for and control all the activities that will be taken care of by the robot. So that's why it is like the brain of the computer, and it will be made of processors, microprocessors, etc., that you might have in your mobile phones or your laptops, etc. Something similar, which are specifically designed for a robot. So you have a controller. Then apart from controller, we have sensors. Now these sensors are like the sense organs in our body. These are like the sense organs in our body. Can you name the sense organs in the body? Which are the sense organs? Yeah, 5 of them. Can you name them? Skin, eyes, ear, nose, tongue. Correct. Right? So these are 5 sense organs. What is the role of the sense organs? That they are in contact with the external world. Correct? Eyes, ears, nose, tongue, skin. These are in contact with the outside world, and that's why they'll gather information about the outside world and they'll pass the information to the brain. And brain will take a decision based on the information received from these sense organs. Similarly, you have the sensors, and the sensors will also have a very similar role. That sensors will also be connected to the external environment. They will sense and try to sense their environment, and they'll send the information to the controller, and controller based on the information received from the sensor will take a decision. So that is how we see that sensors basically work in a very similar manner as how sense organs work. Then after that we have actuators. Now these actuators, they are called as the muscles of the robot. They're said to be the muscles of the robot. Now, the reason why they are called as muscles of the robot is because they help in movement, the movement of the manipulator and the end effector. By doing what? By converting the stored energy into mechanical work. That's the role of muscles in our body also, that muscles will help in a lot of voluntary and involuntary motion in the body, and for that they would utilize the energy that we have in the body, the energy that you are getting by eating food, right? So that energy that you're getting, that energy is something that will be used up by the muscles. Similarly, the actuators also will do the same. the power that you're getting from the battery, from the electrical connectivity, that basically will be converted into mechanical movement, and that's the role of an actuator. Then after that we have manipulator. Manipulator is like the arm of the robot, and it will have a very similar function to what the arm also does, that it will help in the movement, or if you have to place something, go from one place to another, we see that arm basically has a role to play. A very similar role will be played by the manipulator of a robot. And then lastly we have the end effector, which is like our hands. So the final job will be performed by the end effector. So when you have to pick something from one place and place it somewhere else, so all these kind of activities, they basically are done by the end effector. So in this sense we see that there are all these different parts of the robot, and understand all the value that they have and how they are working in tandem to make the mechanical movement happen in a robot. So these are called as the components of a robot. So you have the controller, coordinates all the movements of the mechanical system, and as I told you, it's like the brain, right? It is like the brain of a robot. Then we have the actuators, discussed that these are like the muscles of the robot, and they would convert the stored energy into movement. That is the role of actuators. Then we have the manipulators, which are like the arms of the robot, and that's where they will help in movement of the materials, parts, tools, or special devices through various motions to provide useful work. Then we have the hand of the robot, called as the end effector, and the purpose of grasping, lifting, transporting, maneuvering, performing operations, all these things will be done by the end effector. And then, as we discussed, we have sensors, which are like the guides to the robot's behavior. And these are like, as I told you, like our sense organs. They have a very similar role as the sense organs in our body do. And then lastly, you'll need a power source, correct? You'll need a power source. It's like the nutrition, it's like the food that we eat. So similarly, you will need the power source, which will provide the required power for the movement, or rather the basic working of the robot. So that's why these are all the critical components of any given robot. Now, when it comes to robotics, we see that there are various different applications of robotics, right? So for example, in military applications, if you look at this particular, do you know the name of this robot? This is Daksh. The name is Daksh, which has been manufactured by DRDO. Now, Daksh basically is a robot which is meant for search and rescue operations. Search and rescue operations. So search and rescue operations will be carried on by Daksh. So now what we see is that Daksh will basically Daksh has been prepared by DRDO. Similarly, there are others also. So in military applications, we see that there are a lot of ways in which robots can work. Even if you want, you can attack the army with the help of your robotic army, and it's not a way ahead in the future. It's something that already has been tried by a lot of some of the countries, and it can basically become a possibility in the future. Then in industrial applications, we see that again, whether it is for assembly or for welding or picking up things or doing a workpiece, etc., in all these cases we can make the use of robots. This, for example, a very famous robotic arm called as Skara. So Skara has been one of the very popular industrial robots that has been used in a lot of different industries. Then after this, in agricultural applications, that even in agricultural applications, whether it is about harvesting or placing seeds through the drones, all these things, or even soil analysis, all these things can be done by the robots. Now in India, although we have not seen this happen, in India we see that agricultural applications is not where robotics is being rather used, but it's possible. And for various different tasks which are related to agriculture, we can actually make the use of robots. Then in medical science, where we have surgical robots, we have rehabilitation robots, we have different types of robots that can do various tasks. But largely what we see today is that surgical robots have started becoming very popular, and they are being adopted by many hospitals. Now again, in India, the penetration of these surgical robots is pretty limited right now, but we see that here also the numbers are rising. Some of the big private hospitals, they already have started using some of these surgical robots, and especially in something which is called as precision surgery. Or the long surgeries where you need the precision to be very high. In these kind of cases, we see that robots are being tried. So that's why in medical science also we see the applications. Then after that, we discussed about nanorobots. We understood what nanorobots are, the nano size machines or carbon nanotubes, etc., which can also be used in some of the robotic systems. So that basically is also something which is doable. So that's why we know that there are multiple different applications. Even in outer space applications, we see that robotics can be useful. Can you name this robot? Do you know the name of this robot? Many of you are writing Sophia, but it's not Sophia. Correct answer, as a lot of you have written. This is Vyomitra. This is a robot that has been made by ISRO, and it is supposed to be a part of our Gaganyaan mission. It is supposed to be a part of the Gaganyaan mission. Now, in this particular scenario, when it comes to Vyomitra, now Vyomitra robot, for the first time, ISRO would be trying a robotic mission, and of course, if it succeeds, this is also another step towards deep space missions of ISRO. So, for example, if you remember, we also discussed about RTG, where RTGs will be useful in deep space missions with nuclear technology. So all these basically you can say are smaller components that is preparing ISRO towards a possible future deep space mission that ISRO might take. So that's why we see that there are all these application areas where robotics can become specifically useful. Now, coming to the challenges, the problems that we see in India right now, first and foremost, lack of hardware ecosystem. That the hardware that is required, the manufacturing material that you need for manufacturing robots, we see that they are mostly not there, and we have to acquire a lot of them. Then a lack of financial incentives, because we see that the governments do not want to really take up robotics, and they do not even want to provide any support to anyone who's using robotics. So that's why even if a private company in its manufacturing or its delivery, even if it is using robots, then they are there on their own. It's not that they'll get some kind of tax benefits or some kind of incentives, etc., from the government. There's nothing like that. And then the lack of required knowledge, that we also have been pretty limited in the knowledge that we have with robotics. It's not been traditionally a part of the education system. Now just look at where do you read about robotics. Until class 10th, there is no mention of robotics anywhere in any syllabus. Even in class 11th and 12th, even if you have taken science, even then you don't read about robotics. So after class 12th, a lot of people will go in pure sciences. Many of the students will go to medical sciences. And even in the people who are gone to engineering, it's not that every engineer will also read about robotics. So unless somebody becomes highly specialized in a branch, then only they read about robotics for the first time. Otherwise, there is no mention of robotics anywhere in the entire curriculum. So that also is a problem. That also is a problem, that you are not even introducing robots in even the simplest of the ways. You are not introducing robots to the students, so you don't even know if they would be interested going further. That perhaps, let's say, if they study about it, they might have some kind of knowledge and maybe some kind of interest going further. But that's not happening, and so that's why there is a lack of required knowledge also when it comes to robotics. So that is why we see that there are all these issues, and that's why we need to understand that if we want to build a future of robotics in the country, there are steps that we'll have to take. What are these steps? First and foremost, identification of first wave technologies. Now when we say first wave technologies, we basically are talking about where do we want to begin from. So basically this is about where to begin from. We need to identify that. Because see, what happens is, suppose mobile phone, all right, if you're talking about mobile phone. Now mobile phone, when it started, mobile phone did not have internet, it did not have a camera, it did not do anything else. It just enabled you to talk on the phone while you are mobile. That's why it was mobile phone. But then we saw that slowly and steadily there were so many features that layer by layer were added to the mobile phone, right? So in this manner, the first wave technology was only that it should be able to connect you to the world while you are outside your home, and then later on all these other developments kept on happening. So similarly, in case of robotics also, if you want the development of robotics in India, we'll have to identify these areas. We'll have to identify where exactly do we want to begin from, so that then further steps can be taken in the development of robotics. Otherwise we'll be nowhere. So that's why we need to understand that. So for example, defense is a good way to start, right? Defense is a good way to start, because even if you are applying robotics in defense, it's not that people are losing their jobs. It will enhance your security in some way or the other without really having uh, a lot of problems, right? Without creating a lot of problems for the job market in the country. So that's why we see that this could be a good way to start. Similarly, in other technologies, I mean, higher technologies which are not really related to people in general, even space technology, for example, not related to people in general. So that's why in these kind of areas, even if we start defense or space, if we even if we start in these kind of areas, it's not going to bother a lot of people, right? It's not going to eat up jobs of a lot of people. But when you, let's say, apply this to manufacturing, to automation of these industries, that is where large scale job losses will happen. So that's why we should not touch them. And even if we want to, we have to look for alternatives for the people first. So that's there. Then optimization of resources is required, that whether it is about human resources or the resources that are required for manufacturing, we need to optimize the resources so that we can do it in a cost effective manner. Similarly, we'll have to improve upon the productivity of all these areas as well. If we want to move ahead, then a lot more of industrial robots have to be built, because that is how we can improve our industrial productivity. This will basically lead to improving of our productivity, and that is why we have to think over how exactly that can be done without hampering the job prospects of people. Then academic support is required. We discussed that unless you are specialized, you do not really read about it. So that's why a better specialization, even for the people who are in these kind of fields, who are already studying about robotics, they also need to learn better. So that's why they also need a deep specialization in all these fields. And then lastly, to ensure the safety and the quality of the products that are related to robotics, which are related to all the robots that are being manufactured. So there are all these things that we'll have to do. So whether it is about overcoming the challenges of the present or thinking about the future without hampering the future of the people of the country. So that all is not going to be easy. And that's why there are small steps that will have to be taken so that you march towards a better economy, a better productivity, and you are not hampering anybody's prospect by doing that, while doing that. So that's why there are all these things that we'll have to understand when it comes to robotics. So a small chapter, not a lot to read, because there aren't a lot of developments that have happened in the field of robotics. But the next chapter is really going to be very, very important. And this is the chapter of artificial intelligence, something that hasn't been mentioned anywhere in your syllabus. neither in your prelim syllabus nor in your main syllabus, but questions have come and questions will keep coming from here. This is going to be one of the most important areas even for the next year. This year we saw that in the mains examination they did ask a question. Before this there was a prelims question that was asked a couple of years back. Going forward, keep expecting that questions will come from here, maybe largely based on current affairs, maybe based on the static areas of what we are doing, but questions will come from here. So artificial intelligence, but before that, if you have any questions, if you want to ask anything. Yeah, generative AI, deep fake, etc. we'll discuss in this particular chapter. What is RTG? RTG is radioisotope thermoelectric generator. If you remember in nuclear technology applications, we had discussed it as a point. You're going so fast. I'm not really going fast. I'm really not going fast. Because there are some areas which are factual. So there is no point in just sticking to those areas. Wherever it is required, the explanations just go on. Yeah, plutonium based RTG, correct. Why only female robots are made? You'll have to ask those questions to the people who are making it. How to inject nanorobot into the human body? Uh, the basic operation is actually complex, but the idea here is to inject it inside the blood vessels, helping uh, in the direction of the movement of those the blood vessels or the blood cells. But there's an entire procedure that is used to do that. What does optimization of resources mean? Optimization of resources basically is uh, to use only that much of resource that is really required, to not waste the resource. So whether it is, let's say, the material that you are using or even the human force that you are using, so in any case, not overusing the resources, not wasting the resources is the optimization process. Difference between robotics and AI? We have not started AI, just wait. How graphene is used by flip phones? I mean, graphene is used because graphene is strong and graphene is bendable, it is flexible. That's why it is used. In defense sector, do they allow robots as soldier? Not yet. Not yet. I hope not in the future also. Robots like Vyomitra, Sophia also have AI. Yes, at a scale, yes, they do. How to make notes for science and tech before prelims? I mean, you basically have to keep adding current affairs to whatever we are discussing. Whenever you get something or wherever some important concepts come up, please keep adding them. So that will really help you in one way or the other. So because so that at one place you have everything, and that will help you to just go through and revise through all these topics once more. Do we need to make separate notes from books, or these PPT are sufficient? As I have been telling this, no book is required in the subject. Just focus on what we are doing in the classroom and add current affairs to it. Do robots have feelings? No, they they do not. They are not sentient beings. Unemployment will be found or not in the future due to robotics implementation? We can't say. There are two ways technology takes in a lot of ways. We many a times we see that uh, technology has helped in creating a lot of opportunities. Sometimes create technology has also killed many opportunities. So that's why it's a road that is very difficult to predict. But overall we have always seen at a larger scale, we have already always seen a positive impact in a lot of ways, and we'll discuss about all that in this chapter also. So artificial intelligence. Now when we talk about artificial intelligence, we know about what is artificial. Anything that we are making man made is artificial. And what is intelligence? Anything that is attributed to our cognitive abilities, the ability to solve a problem, the ability to understand something, to act on something, to comprehend something, decision making ability, problem solving abilities. These are intelligence. So intelligence does not only mean that somebody is scoring very good marks in the examination. That's not the only definition of intelligence. Anyone who is good in problem solving, decision making, uh, any cognitive abilities like to think, to comprehend, to act, all these things will be attributed to intelligence. So that's why uh, when it comes to when it comes to these kind of scenarios, when it comes to these kind of scenarios of adding intelligence, so understand that when it comes to adding intelligence to or artificially to a machine, it means that you are trying to make them have some kind of problem solving abilities, some kind of comprehension activities, so that they can do something for you, they can solve some kind of problem which becomes very complex for us to manually solve. So that is where we see that artificial intelligence helps. So if you look at the definition, we are talking about an ability of machines to perform cognitive tasks like thinking, perceiving, learning, problem solving, and decision making. So any machine that can do all these tasks should be called as artificial intelligence, or a constellation of technologies that enable the machines to act with higher levels of intelligence and emulate human capabilities of sense, comprehend, and act. And learning and problem solving abilities are also attributed to artificial intelligence. So when you can instill all these properties inside some kind of software, some kind of machine, then it will be called as artificial intelligence. So that's why artificial intelligence is where you are doing all these things, you are helping in doing all these kind of activities. And that's why I understand how it's different from a robot, because robot always has to do a mechanical work. So for example, let's say if just a calculation is being done, then it's not robotics unless there is a movement, unless there is a work involved. And it's not always artificial intelligence. It's just a bunch of programs written so that whatever be the function or whatever be the scenario in front of it, it has been exactly designed to do that. So it will not be able to change itself or adapt itself if it is not based on artificial intelligence. So that's why there's a big difference, and it's a big step up from what just robotics was. So that's why artificial intelligence today, we see that it has taken a very different form. Now when it comes to artificial intelligence, today you know that artificial intelligence is everywhere. From the biggest of the things to the smallest of the activities, we know that artificial intelligence is working everywhere. So whether it is space technology, where all the images that we get, all the videos that we get from our remote sensing satellites or the earth observation satellites, they all have to be processed very fast. So for that image processing, we will be using artificial intelligence, and with the help of artificial intelligence it will be able to solve those issues. Similarly, in solving agricultural problems, in understanding weather patterns better, we see that we have been using artificial intelligence in the past few years. In the medical science, in prediction of diseases, in making of vaccines, in all these biggest, that's why I'm saying that all the biggest of the problems of the world are being solved with the help of artificial intelligence. At the same time, even the smallest of the things that you are doing every day or you are involved with every day also uses artificial intelligence. Many of the mobile phone apps that you're using, they're using artificial intelligence. So for example, let's say why an Instagram has to make an algorithm that you keep on swiping the reels, forgetting about your examination, forgetting about your targets, keep swiping. So they'll make the system in a manner that they are giving you what you want, they are giving you what you basically will be involved with. Similarly, in a lot of different apps, everyone who is uh, designing something today, they're designing it because they know the value of it, They are designing it because they know that they are going to uh, uh, retain their customers better if they're using artificial intelligence. Because in our when it comes to artificial intelligence, they will use the data so that they can give you the required data accordingly, or they could give you the required experience accordingly. And that's why we see that in advertising also they'll be using it, in search engines they'll be using it. Or even if, for example, small example, let's say, if you just go and search for something on some of the app, let's say on Flipkart, Amazon, you go somewhere and you just have search for something, you search, maybe you did not buy, you came out, and then after that what you'll see is that even if you go on Google, even if you are going on the internet and searching something, you'll see that those advertisements will keep coming back, right? Those advertisements will keep showing up. Similarly, if you have maybe talked about something, messaged something, you'll see that those advertisements also will start showing up in your feed. So all these things happen, and things have gone farther from there. um, it happened last year. There was a classroom batch that I was taking in Chennai, and there I must have uttered the word solar energy a lot of times. So obviously your mobile phone is listening to everything that you say. This time I did not get any advertisement. I did not get any targeted advertisement. I got a phone call 2 days later. 2 days later, on a Tuesday, I get a phone call where the lady on the other side of the phone says that, "Sir, are you looking for a new solar energy connection?" That just startled me. That I did not even do a lot of search on the internet or anything. I just was saying a lot of. Uh, I was using the word solar energy. I must have used the word solar energy a lot of times. That was it. And we know, and I'm sure that you have similar experiences about all these advertisements and the targeted advertisements, etc. And all of this is what? All of this is nothing but artificial intelligence. But now we see that artificial intelligence has started to move to another level with generative artificial intelligence, which perhaps we'll talk about tomorrow. So with generative artificial intelligence, now we see that the world is growing further, and now artificial intelligence has started to take the next step. Until now, it was more about just the analysis of the data, understanding of the data, predicting the patterns, and doing a basic job based on that. So with everything that artificial intelligence had done, it was still a very trivial form of artificial intelligence. But when generative AI starts to come to the world and show its face today, we see that the things are pretty different. So when it comes to artificial intelligence, there are layers that design artificial intelligence. We have something called as machine learning and deep learning. And these concepts of machine learning and deep learning, they are helping in the design of artificial intelligence. Now, what do we mean by machine learning and what do we mean by deep learning? So machine learning, the machine is learning. The ability of the machine to learn without being programmed is called as machine learning. Meaning that instead of programming it explicitly, you are training the machines. You're training them to act in a certain manner. So that is called as machine learning. Now, for example, let's say a Google search, that if you do a Google search, you start typing, you will see that they will try to end your sentences or finish your sentences, right? Why? Because there are so many people who have searched something similar. So something which is the most common search will be pushed up. Something which is the most common search, maybe in your area, maybe in your state, maybe in your district, will be pushed up. So we'll see that these kind of customizations will happen. And this is where the machine is learning, because a lot of data has been fed and it has started to understand the pattern. Even for example, let's say you'll see that while even typing on the phone also, you perhaps might see that. Or uh, if you use Gmail, you'll see that you start writing Gmail and you'll see that it will keep on finishing your sentences. Why? Because there are millions of users all across the world who have used the Gmail services, and that's why Gmail has picked from there. The artificial intelligence used there, or the machine learning system used there has picked from there. And that's what machine learning is, that you are not explicitly programming for each and every step, but rather you are programming that training. You are programming that training module so that it gets trained on data, so that it can predict results based on that training. So that's why instead of hand coding the software libraries with well defined specific instructions for a particular task, the machine gets trained using large amounts of data and algorithms, and in turn gains the capability to perform specific tasks. So this is basically what we see with machine learning. So even, I mean, for example, another example let me give you. Let's say you use calculator, right? So calculator is a simple machine that you type 2 plus 2 equal to, and you get the result 4, not based on artificial intelligence. Just that programming has been done so that it will give you the correct mathematical result. Let's say the same calculator was based on machine learning, or it was using machine learning. What happens then? Then what happens is that if, let's say, you have typed 2 plus 2 equal to 50 times or 100 times or 200 times, then it starts to learn, and it starts to understand that this is some weird person who likes typing 2 plus 2 equal to all the time. So next time when you start typing 2 plus 2 equal to, as you type 2 plus, it will finish your plus equal to and give you the result, perhaps, if it was based on artificial intelligence. But because these are not based on artificial intelligence, these are simple programmed machines. So that's the basic difference between being explicitly programmed and being trained. That's the difference that basically comes in case of machine learning. Now, another type of machine learning is deep learning. Now, in case of deep learning, what we are saying is that it is a much more advanced version of machine learning. So deep learning is not different, but it's an advanced version. As advanced version of machine learning. Now, why am I saying that it's an advanced version of machine learning? The reason is that deep learning is where we see that it can process a wider range of data resources, requires less data pre-processing by humans, and can often produce more accurate results than the traditional machine learning approaches. So that is why we are saying that it's advanced, because the training required will be less, the accuracy will be higher, the results that they'll publish will be faster, and they'll be able to process a lot more data in a very short span of time. So when these kind of systems are being deployed, they are called as deep learning. Now, in case of deep learning, we see that they use something which is called as neural network. They use the services of something called as neural network. Now, when it comes to neural network basically is like a bunch of neurons, something similar to what works for us also. Like, for example, we also have the nervous system, right? We have the nervous system. And what does the nervous system do? It will keep on sending and receiving the data from all across the body, from the brain to different parts of the body, from different parts of the body to the brain, and from one part of the body to another. So all these kind of activities will be done with the help of the nervous system in our body, correct? So something similar is being done by the neural network, that the neural network also will try to comprehend the data with the help of bunch of hidden layers. So in these hidden layers, all the computation will happen, understanding of the data, processing of the data will be done, and ultimately an output will be given. So in this manner, we see that there is a very complex neural network that can also be designed, which will help artificial intelligence. It will help deep learning in getting the data faster and getting a much more accurate result with that data. So that is how we see that all these hidden layers will act as a part of this machine learning system, or rather the deep learning system. So that is how we see that the network basically can ingest vast amounts of input data, and then they can process them through the multiple layers that learn increasingly complex features of the data at each layer. So this is ultimately how they will keep on learning. And this is how the various different kinds of artificial intelligence work. For example, in image processing, so if let's say you have fed a lot of data with regards to similar images, it will be able to comprehend the images much better. So for example, in crime analysis, etc., image processing is used. That let's say you have somebody's face, or somebody who is wanted, let's say you have their face, then in that case any variation of the face can also be predicted with the help of deep learning. Not only that, even from the even from the crowds it can pick it up, from different cameras which are online all across the country, maybe it can pick it up. So that's why then in that case image processing will be able to pick up that face wherever it is found. Even if they find a certain kind of match, they'll be able to do it. So that's why these kind of facial recognition or image processing can be done with the help of deep learning systems that employ neural networks. So that's why we see that there are all these things that are actually helping in making the systems perform better with much higher accuracy in a lot lesser time. Now, there are different types of artificial intelligence, but let's start from here in tomorrow's class. So, what is weak artificial intelligence, strong artificial intelligence, generative artificial intelligence, narrow artificial intelligence, all these things, super intelligence, we'll discuss in tomorrow's class. So, if you have any doubts, please let me know. What are the hidden layers here? What role do they play? So basically these hidden layers, you can say that these are more of algorithms and flowcharts. These are algorithms and flowcharts which help in the computation of data. There'll be a bunch of yeses and nos, that whether to go in this direction or that direction, or what to do and how to get to the result. So that's a complex layer that is designed there. Leaderboard for the day. This is the leaderboard. Please differentiate between AI and deep learning. So, AI and deep learning are not different, but deep learning is a kind of artificial intelligence. So, artificial intelligence is the entire human brain, like the entire human brain, and deep learning is a way in which the human brain works better. So, that's why deep learning is nothing but a kind of artificial intelligence. All right, it's a kind of artificial intelligence which is highly accurate, which is very fast, and it does not require a lot of training. So that kind of artificial intelligence is called as deep learning. Can AI code itself? It's possible. You can train it. Difference between AI and AGI. General intelligence we'll discuss tomorrow, so I'll tell you about it tomorrow. Wonderful. So a lot of you have gotten everything correct today. Congratulations to everyone. Good going. Tomorrow, is there a class? Yes, tomorrow 5 p.m. there is a class that we'll have. We'll continue from where we are leaving today. If robots do not have any feelings, how will they understand somebody giving order to them? Because it's programming. They have been programmed to follow the order. So that's why they'll follow it. So for example, when you type 2 plus 2 equal to in a calculator, it does not have an option to not give you the result as 4. It has been programmed. It will have to give the result as 4. So it need not have to understand you, need not have feelings. I'm giving examination 2024. So if I start to learn today, how can I? It's too late if you are starting today. But I'm hoping that there are certain areas that you've done. But if not, then you have to understand that there's a very limited time that you have in your hand, and you have to start preparing accordingly. you'll probably not be able to complete all the parts of the syllabus. So you'll also have to pick and choose. If, I mean, hypothetically, if you are starting today. So please talk to the mentors. They can guide you in detail about how exactly this can be achieved. And it's not that it hasn't been achieved. There are people who have done it. There are people who have started in December and they have a 2-digit rank. So it's not that it cannot be done, but just that it's going to be extremely difficult. How machine learning different from deep learning? As I told you that deep learning is a much more specialized version of machine learning. So that's why it is much more accurate than normal machine learning approaches. It's much faster than it, and it does not need as much training with data as machine learning does. Yes, tomorrow onwards 5 to 8:30, the same timings for the class. Monday, it's the last class. No, Monday is not the last class. Wednesday is the last class. So Saturday, Monday, Tuesday, and Wednesday, we are left with the last 4 classes. In accordance with the time we have in our hand, do we need to study, choose, right? No, it should not come down to choosing. You have to always understand that it should not come down to choosing. You have to give yourself enough time that you complete each and every part of the syllabus, because you never know where the questions come from, first and foremost, and where the easy and the difficult questions come from. Now let's say you study selectively, and the things that you have studied, although they were important, the questions that are asked are difficult, and the areas that you left out, they asked easier questions from there. So that's why, as much as possible, we should not leave anything to chance. Every part of the syllabus should be seen as being equally important without any exception. Difference between chat gpt and AI? Chat gpt is a kind of AI. Will you also teach us environment? I think environment classes will be taken by Mukesh Jha sir, if I'm not wrong. Sunday we don't have any class, no. All right. So this is it. Please go back, revise all these things once more. If you have any doubts, please bring them back tomorrow. We shall discuss them. And tomorrow we'll start with all the different types of artificial intelligence, which are based on these certain concepts. Thank you.